So we're continuing our video on confidence intervals here. Last lesson we looked at how we can calculate the confidence interval using the formula and using our graphics calculator. This video what we're doing is we're going to be working on how can we find a sample mean and also the standard deviation. And that's why it's important that we know how this formula itself works. Let's recall back when we looked at the confidence interval. We recall back that this part here was your lower and this part is your upper. And when we calculated the answers, we got a confidence interval width of your lower level and your upper level. When we look at this formula here, we have your mean values there. So what we've been asked to do here is we want to work out, well, how can we work out your sample mean? And the best way to work this out is by stating what the average is of the widths. So if we take our two widths and add them together, so 5.617 plus 9.4383, we then get approximately 18. Now that we've got 18, we're just going to divide both sides by 2, and we find that our mean, or our sample mean, is equal to 9. So why does this work? It's because these two here are the widths. And if I want to work out what the total width is, I can subtract them away from each other, or in this case here, we're going to add them to get that total width so I can find the average to find these means. Because remember, x bar is another word for average when you're looking at statistics. Divide by 18 and you get x bar 9. So let's just pop this over here for now. And let's take it to the second question. The second question here is asking us, well, hence, calculate the standard deviation. Now, whenever you see the word hence in statistics, and I'm just going to quickly write these down here again, 8.5617 and 9.4383. Whenever you see the word hence, it means use the equation that you've just made to solve this question. So it says hence calculate a deviation and the population standard deviation, which was used to calculate the confidence interval. So let's now write this down with the information that we do have. We have 9 minus 1.96 deviation over the square root of 60, because it said we had a sample of 60, is less than equal to mean, less than equal to 9 plus 1.96 deviation over the square root of 60. This is where I take you back to looking at the lower and the upper, and these two values. We know that these two values, because it shares a similar midpoint, I can work out one side, and whatever I get for a deviation would be equal to the opposite side over here. That will give me the solution for the upper end. So in this calculation, let's use the lower end and see if we can work out what our deviation is going to be. So the lower end would be 9 minus 1.96 deviations over 60 is now equal to 8.5617. And all we're doing here is just rearranging this formula so that we get deviations by itself. So if we bring over 9, we get negative 0.4, what do I get? 0.4383. 383. Divide both sides by negative 1.96. So deviation is equal to the square root of 60 is equal to dividing this side by negative 1.96. We get 0.022, what do I get? 2236. And then we just multiply this side here by the square root of 60. So therefore, this here will equal 0.2236 times the square root of 60. So therefore, we get approximately 1.73. And that's understanding how this works. Without a good understanding of how the standard deviation, how the confidence interval works, and how it relates to the solutions, we wouldn't have a way of being able to solve this type of question. But how do I know that this answer is correct and this answer is correct? I'll just plug straight in my calculator. So let's plug those in. We now know that x bar is equal to 9, standard deviation is equal to 173, and n was 60. Now remember, this here is a simplified answer, so it may be a little bit off. So let's have a look. So we go back into our calculator. Let's go back up. Standard deviation was 1.73. Your mean was 9, and we were on 60. And we get very similar answers to what we started off with. Sorry. So when we're working with confidence intervals, we can reverse the formula to help us work out an unknown mean and an unknown standard deviation. Next video we'll look at changing z-scores and how we find the z-scores using the graphics calculator.